Pick up right where we left off with addition and subtraction of rational expressions. The only thing that's different is that we may now see denominators that have multiple binomial factors. Okay, so up to this point, the denominators have been a monomial or maybe a monomial times a binomial, that kind of thing. Now we're going to have questions where we have multiple binomials in the denominator. This is considered a standard of excellence question. Okay, so I spoke a little bit about that at the beginning of the course, but standard of excellence questions are roughly 20% of the questions you'll see. But honestly, it's not really that much different than what we've already done. Okay, so when we're solving these things, or I should say solving, that would be for an equation, when we're simplifying these things, what is the first thing that we need to do? Factor everything, right. So if I look at my first rational expression, 32 over x squared minus 16, can I factor anything there? Yeah, where the denominator, how do I factor that? It's a difference of squares, yes. So my numerator will be 32 over x plus 4 times x minus 4. And then plus 2 over x plus 4. Okay, that one's already factored. Okay, what now? Yep. Yeah, figure out what the LCD is. Okay, what do you think the LCD is in this case? X minus 4? Yeah, it's got to be both. Because we have to be able to see every factor from each denominator. So if I take these two, I got to have at least these two in there. But then when I look here, this one has already been accounted for. So my LCD is x plus 4 times x minus 4. Okay? While I'm thinking about my denominator, what would also be a good thing to do? Non-permissibles, right? So what can x not equal here? Yep. 4 or negative 4. So you guys may have noticed that I've written this before, but I never actually explicitly said what that means. This we say as x cannot equal plus or minus 4, meaning positive 4 or negative 4. So you can do that. You can just list both numbers, whichever you want. Okay? Okay, so now we have to think about multiplying either one or both rational expressions by some nice version of 1 that allows us to get our common denominator. Okay? So this guy already uses the common denominator. What factor is missing from this denominator? X minus 4. Yeah, so here I need to multiply this guy by x minus 4 over x minus 4. Okay, and now I can write this as a single expression because the denominators are the same. So the only thing, though, is that when you simplify the numerators, you need to expand here, right? So this will equal, I'm just going to put my denominator in there, okay? From this rational expression, 32, and then from this one, I have to add 2 times x minus 4. So 2 times x is 2x. 2 times negative 4 is minus 8. Okay? And then we can collect like terms and simplify the numerator. So we will have, let's see, 2x, and then 32 minus 8 is 24, plus 24, over x plus 4 times x minus 4. Okay? Now, tell me about this numerator. It can be factored, yes. So if you can factor the numerator, if the numerator is factorable, you have to check to see if one of the factors in the numerator will be the same as one of the factors in the denominator. Because if it is, you can simplify further. Okay? Now, if you can kind of factor this in your head and see that this is going to be 2 times x plus 12, and you're like, oh, well, I can't cancel anything anyway, then just leave it. Okay? But it is a good habit to get into, to just take a step back, look at it again. Can I factor it? Okay? And you can leave your answer as either or. Okay? It is a good habit, though, because what people do is once they get to this stage, they're like, oh, I'm done. This is great. Right? When sometimes you can factor further. And if this was a multiple choice question, and there was something that could be factored further, and the question might say, which is the most simplified form of this expression, then that might be, what's it called? A distractor, right? Do you guys know about distractors in multiple choice questions? Yeah, so it's like an answer that we think you may get along the way that's going to throw you, right? So you have to kind of make sure that you're thoroughly going through and checking every time, okay? If you can see in your head, oh, nothing's going to simplify there, that's fine. But go through that thought process. Okay, let's try a couple more. So we are going to start by, again, factoring everything. In the first rational expression, what can we do? Yeah, factor out of 2. And we're left with x minus 3. Okay? And then in the second one, how can we factor that? Difference of squares. Okay. All right. Now what? Yes. Say that again?
You need to multiply, wait, never mind.
Okay. No, that's okay. Yeah.
Wouldn't you multiply the 4x over 2 and then x minus 3 by x plus 3 over x plus 3?
So that's one piece of it. So you're kind of going a step ahead, which is let's try and achieve this common denominator. Okay. You may want to, though, break that up. So, okay, what is the LCD here? Well, we have to be able to see within our LCD all factors of all denominators. So we need to at least have that. That's got to be in there. And then in the second rational expression, we already have this factor covered, but we're missing the factor of x plus 3. Okay, so that is our LCD. What's our non-permissibles? Yeah, x cannot equal plus or minus 3. Right. Okay, so now we can go through this step of achieving that LCD. And by the way, if you want to skip this step, that's fine. But I find sometimes, like, when people try and skip ahead too much, they make mistakes. So you have to sort of judge for yourself what you can do. Yes? You're good? Okay. All right, so in the first rational expression, we are missing the factor of x plus 3. So I'm going to multiply this by x plus 3 over x plus 3. And in the second one, we're just missing a factor of 2. Okay? So let's keep going here. I can now write the entire denominator all together. There we go. And then here in this first guy, I have to do some expansion, right? So 4x times x is 4x squared. 4x times 3 is plus 12x. And then here I've got 2 times 3, plus 6. Okay. Is that it? Yep.
We can factor out a 2 and a 9.
Right. So when I say, is that it, you typically want to look to the numerator and see, is there something I can do there? Because if that's factorable, it's possible that one of the factors in the numerator will cancel with one of the factors in the denominator. And that's exactly what happens. We have 2 times 2x squared plus 6x plus 3 over 2 times x minus 3 times x plus 3. And then those cancel. OK, so that's it. Now, before we move on, I want you to take a look at the first rational expression that we factored, this guy. Take a look at this. Tell me what you notice. Yeah, we could have actually simplified there first. And then we wouldn't have had to take out a factor of 2 at the end. Okay? So I didn't go there because nobody suggested it, which is usually because nobody really thinks about that, right? But it is kind of worth just maybe taking a step back and saying, oh, is there anything I can do here first? Because sometimes it can make that process at the end a little easier. Okay? So you could have also canceled the 2 there, had 2x over x minus 3. You wouldn't have had to do it at the end. Okay? All right. Let's try one more. Okay, so we've got x minus 9 over x minus 3 minus 2 plus x over x plus 4. Okay, so is there anything here to factor? No. Okay, everything's factored. So let's talk about our least common denominator then. Okay, what do you think the LCD of these 2 rational expressions would be? Bingo, yeah. So I don't know if you guys heard that. But if they are factored and they are not identical, you have to include both of them in your LCD. It's like when we were looking at adding 2 fractions where one denominator was 3 and one denominator was 5. The LCD was 3 times 5. So if they're factored and there are no common factors, then the LCD is going to be the 1 times the other. Right? And from here, we can also state our non-permissible values. X cannot equal 3 or negative 4. Okay, and then let's kind of just spread this out a little bit. So we've got x minus 9 over x minus 3. You'll notice I put brackets around all of these binomials. And that's because I'm thinking, OK, if I'm multiplying numerator and denominator by something else, I need to multiply that by all of the numerator and all of the denominator. Okay, and then minus 2 plus x over x plus 4. Okay, so take a look at the first rational expression. Which factor is missing? X plus 4. So I have to multiply that one by x plus 4 over x plus 4. Okay, and here the missing factor is x minus 3. Okay, so this is a big step. If you're here, you're in good shape. But then this one involves a lot of simplification, okay, because we need to, in the denominator, we can make the denominator now just x minus 3 times x plus 4. But we have to expand and simplify all of these numerators. Because if I expand here and I expand here, I'm going to have like terms. And I can collect those. Okay? Now, this is a subtraction question. And this, in subtraction questions, we can get ourselves into trouble if we take too many steps at once. So what I would do here is set it up where you have a single denominator, and then you're going to have this minus this. And in here, you can do that expansion so that you remember essentially to subtract all of this times this and not just part of it. Okay, so let's apply our distributive property to expand this out. We're going to have x times x is x squared, and then x times 4 is plus 4x minus 9x, and then minus 36. Okay? And then here, if you want to, by the way, you could write this as x plus 2. Some people like that format. But at the end of the day, you're still going to get the same answer. So 2 times x is 2x. 2 times negative 3 is minus 6. And then x times x is x squared. X times negative 3 minus 3x. Okay? Now, just because I don't feel like writing this like 500 times, what I'm going to do is just above, I'm going to simplify each of these individual things. So this becomes x squared minus 5x minus 36. And this guy will be x squared, and then 2x minus 3x is negative 1x minus x minus 6. Okay, so that in my next line, I can kind of do two things at once. Okay. So this is where you have to be careful, because remember, this subtraction applies to all of these. So take your time when you distribute that negative sign in, right? This is just, there's, the coefficient here is 1, so you can just remove the brackets. But then here we're going minus x squared minus negative x is plus x. And then minus negative 6 is plus 6. Okay, and that's where a lot of people make mistakes. They subtract the first term, but then they don't do anything with the second two. Okay, and now we can completely simplify this. So the x squareds make 0. X squared minus x squared is 0. We have negative 5x plus x is 4x. No, negative 4x. And then negative 36 plus 6 is plus 30 over x minus 3 times x plus 4. Okay, yes? Yes, it is. It's negative 30. Okay, now again, if you look at the numerator here, there's a greatest common factor of negative 2. But if you kind of do that in your head, if you take out a negative 2, this is going to be 2x plus 15. It's not going to cancel with anything down here. So there's no point really in factoring that. But you should just do that check-in to make sure that it can't be simplified further. Okay, questions so far? Awesome. So I want you guys to work on these 3 questions. And we will continue this in a couple minutes. And depending on whether you have to correct it or not, you may just want to look for the mistake. In this case, we have to correct it. So we maybe just do this all ourselves anyway. Okay. One thing about the find the mistake, those are usually multiple choice questions where it would be like A is step 1, and B is step 2, and C is step 3, and D is step 4. And it'll say, in which line is the first mistake? Okay. So one thing about that, sometimes people don't know if it's, there can be confusion as it's like this step or this step, if there's a mistake going from here to here. The mistake is always where the equality breaks down. So if this line is equal to this line, there's no mistake here. If this line is not equal to this one, this would be the mistake. Okay? But let's just take a look at this to start off with anyway. So if we are starting to add or subtract rational expressions, what's the first thing we need to do? Factor. Yeah, so this guy is a difference of squares. and then plus 3 plus x over x minus 1. Okay? See anything yet? Yeah, right? First mistake is right here. That was factored in correctly. Okay, so if this was a multiple choice question, you would say A. First mistake is in step A. Okay? We could also state our non-permissibles here. X cannot equal positive or negative 1. Okay, now what will be the LCD here?
X minus 1 times x plus 1.
Yeah, these two factors, right? So we can just multiply this by x plus 1 over x plus 1 because this one is already over the LCD, and over here, this is the factor that's missing. Okay, and then we can start to simplify this, right? So here, this is just an x. Here we need to do expansion. So, and this is addition, okay? So we can just kind of do it all in one line. So plus 3x plus 3, and then plus x squared, and then plus x. Okay, and then the last thing we have to do is just combine like terms. Okay, so we've got, let's see, just one x squared term, so just x squared. And then for our x terms, I have 3x plus x is 4x. And then here,
Shouldn't it be 5x?
yes. Actually, I was thinking, I was looking at this, and I was like, if that was a 4x, it could actually be simplified more, right? So that's not, but it wouldn't be an expectation of this course. So because if it was a 4x, that would be a trinomial that would factor, and one of the factors would be x plus 1. So when I was going through it step by step, I was like, wait a second. This wouldn't really be a fair question to ask because you actually fully simplifying this question is not one of the outcomes of this course. But I made a mistake anyway. So there you go. X squared plus 5x plus 3 cannot be factored, right? But if you get down to a trinomial and there's no greatest common factor, you're done. Consider yourself done. Okay? And that is it. So I would like you guys to try a couple of these. There's a few on the next page. Questions 1 and 2. Your homework is page 249, numbers 3 to 9. I highly recommend you trying a few of these tonight before the quiz. Maybe like, just pick like 2 or 3 multiplication, 2 or 3 addition, subtraction, and 2 or 3 division, right? Do a couple of each.